Okay, so this problem is going to be an interesting one. I'm going to be solving something called addition of vectors, and I thought, to do this, I should probably take a very real life example. So this is the example I've got. I've picked out this image from Apple Maps, and you see this yellow circle right here. It's the cornerstone. Well, that's white right now, but this yellow circle right here is the cornerstone garage, and let's say you have to drive to CP. Okay, so that's where CP is. Maybe I should use something like this. Maybe, yeah. See, that's where CP is, and that's where cornerstone garage is. So what you can do is, like, one of the ways you can get to CP from cornerstone garage is you can start from here and drive down the Avenue of Champions and then take a right down the Rose Street, and then you'll get to CP. Okay, so I have shown that by a different figure right here, and what we are doing is we are going from Cornerstone to CP. Okay, so Cornerstone to CP, so step 1 will be from Cornerstone to Rose Street / Avenue of Champions intersection, and that distance, this distance is 1771.09 feet or 540 meters. Then you take a right, and then you travel 1147.50 feet, and that is how you reach CP. Okay, now let's calculate if you were able to fly from the Avenue of Champions to CP, what will be the distance that you will be traveling. So here clearly the distance, if you're just walking or driving down the Avenue of Champions and then you take right on the Rose Street, it will be 114750 feet plus 1771.09 feet. But if you could fly, from here to CP, you will definitely you will definitely reach there quicker, and you will not need to travel as much as compared to when you need to do a two-step process. First to Rose Street Avenue of Champions intersection, and then on Rose Street to CP. So we're going to exactly found that red distance right there. Okay, so let me just make this diagram, this right triangle, separately, so that we can do some calculations. So we've got this horizontal line, and this is the cornerstone garage. Okay, and this is the first lap, this is the first step. Okay, and let me call this vector A. Vector A has magnitude 540 meters. That's this one, Cornerstone to Rose Street and Avenue of Champion intersection. That is 540 meters. So you're here right now after step 1. Step 2 is from here to CP, and that distance is 350 meters, and let me call that vector B. 350 meters, and that is vector B. Vector B's magnitude is 350 meters. We are also given this angle, and that is 45 degrees. And also this turn right here is 90 degrees. So if I want to figure out what angle B makes below this horizontal, this distance will be 45 degrees as well, because you see this line right here is parallel to this line, and this intersects those two lines. That's why this angle will be equal to this angle. Okay, now let me just write down the coordinate system. On cornerstone, let's say this is the origin, and this is X and this is Y. Okay, so the X and Y, and then origin is on the cornerstone. So if I ask you, what is the X component? What is the X component of the vector A? So vector A, X component will be its magnitude times cosine of the angle that it makes with the x-axis, and that is 45 degrees. So if you calculate this cos 45, you'll see that this is equal to 381.8 meters. Similarly, if you want to calculate its y component, if x component is a cosine theta, y component is given by magnitude times sine of theta, that is magnitude times sine of 45, which will also be 381.8 meters. Okay, now usually in a problem a coordinate system is fixed and that is how you deal about it, but here, just for the understanding's sake, I'm gonna make this coordinate system again here so that we can figure out the components, x and y components of B. Okay, this is not a usual step, this is just for our understanding that we need to figure out the x component and y component of B. So x component of B will be its magnitude times cosine of the angle that it makes with the x-axis, and the x-axis is right here. The angle that it makes with the x-axis is 45 degrees, but because in the component will be right here, which is in the negative x direction, I really need to write down a negative in front of the component magnitude. Okay, so it's going to be minus b cosine theta, and if you calculate that, it's going to be minus b cosine of 45 degrees, where b is 350 meters. The answer will be minus 247.48 meters. Similarly, by, like the way we calculated ay, will be this one right here, that's by, and you can see clearly it's in the minus y direction, so again I have to do this minus in front of it, this time sine, because we are talking about the y component, theta, where theta is 45 degrees, and you will see that it will also be equal to minus 247.48 meters. Okay, now let me tell you that in order to calculate this red vector, the vector that we are looking for, the vector that tells you if you could fly from cornerstone to CP, what the straight line would that be, and we can figure out all kinds of things about it, like the distance that you will be traveling if you could fly from cornerstone to CP, that would be the magnitude of that red vector. What angle it makes with the x-axis, we can figure out that. So let's do that exactly. So in order to do that, we have this equation, right? Red vector, let me just write it as r. Okay, red vector is equal to a vector plus b vector, right? To get to red vector, well, red vector would be something like this. Its x component I cap plus its y component j cap, right? So we need to get to rx and ry. To do this, let me make this column. This is x component, this is y component, this is vector a, this is vector b, and this is vector r. Okay, so vector a's x component is, I'm just looking down the value from here, 381.8. okay, vector a's y component is minus, there must be minus here, because you see its x component, this is vector a, its x component is like this, but its y component is in the minus y direction, so it's minus 381.8. bx is equal to minus 247.48, and by is also equal to minus 247.48. Now r will be equal to ax, not r, but x component of r. Rx will be equal to ax plus bx. So if you add those two numbers, you'll end up with 134.32. And for ry, you add the y components, so you have ay plus by and you'll end up with minus 629.28. So at this point you know the vector. Okay, so if I want to write down this vector, I can just say that this is going to be Rx plus Rx I cap, so it's going to be 134.32 I cap plus Ry j cap minus 629.28 j cap. Now to figure out, so when you have a vector like this, see, when you have a vector like this, to figure out its magnitude or the length, what you do is you square up the individual components and you add them together. Okay, so in our case, if I want to figure out the magnitude, what I'm going to do is I'm going to square the individual components, squared plus minus 629.28, and then I'm going to add them together. I'm going to take the square root. So when you do this calculation, you'll end up with about 643 meters. So you see, the red vector's length is 643 meters. So if you start from cornerstone, and if there's a way you could fly to CP, you just need to travel 643 meters. But if you have to walk or if you have to drive, you'll have to travel 540 meters this way and then 350 meters this way, which is clearly much greater than 643 meters. So that's how we know the magnitude. We can also figure out the angle that this red vector makes with the x-axis. So this is the angle I'm talking about. You know, this is the red vector and this is the x-axis. So this angle I'm talking about, right? So we can figure that out too. So to do that, if you have a vector like this, generally, okay, from the x angle, maybe I should write down that vector x here, sorry, the vector r here. So this is x and this is y. That vector r is this, okay, its x component will be this and its y component will be this. And we know those components because those components are right here, 134 and minus 629.28. So to figure out, let's say, look at this angle right here. Look at this triangle right here. Okay, in this triangle, this is a right angle, right? So we can use the trig function. If I call this angle alpha, we can use the trig function tangent of alpha, which will be equal to opposite, and that side is Ry divided by Rx, because the adjacent is Rx. That is the definition of tangent, is the ratio of opposite and adjacent sides. So if you use those two values, and they will be 600, and then remember this is the magnitude always, right? So 629.29 divided by 134.32. If you divide that, you'll get, let me just quickly grab my calculator, it's going to be 629.29 divided by 134.32. So this is about 4.68, and then to get to alpha, you do this operation, tan inverse of 4.68. Tan inverse is same as arc tangent, if you're wondering. So that is about 77.9 degrees. So now you know what angle that resultant vector, that shortcut distance, makes, which is this angle with the x-axis, and that angle, like this angle is equal to 77.9 degrees. So this is a classic example of figuring out how to add two vectors. You just need to know the components of individual vectors. You add them together to get the components of the resultant vector. You divide the resultant vector, take the tan inverse to get the angle. To get the magnitude, you square up the individual components, add them together, and take the square root.